Welcome to 1.1 example 3, and I actually like these types of questions because I think it really does help visualize what's exactly going on here. So it tells us that a translation has been applied to the graph of f of x. Really important to read those graphs. The original is in blue here, and then the transformed down here is in red. It wants us to determine the equation of the translated function in the form y minus k is equal to f times x minus h. Now, I would like to just point out one more time that h is our horizontal translation, and k is our vertical translation. Now that's really important to remember, and then all we have to do is find out how much it's been vertically translated. And I think the easiest way of doing this by far is to grab the most distinct point on a function and see where it went. And I would argue that the most distinct point on a quadratic would be the vertex, which is 0, 0 on f of x. So I'm just underneath here, going to put a point on f of x, which is 0, 0. Keep in mind that to go from f of x to g of x, what I'm going to do is the mapping, and I'm going to take a point on f of x and add h and k to that point. Got a little messy there, but hopefully you can see that. So if we look at the point 0, 0, then what's going to happen here is that we are going to have 0 plus some h value and 0 plus some y value, and that is going to give me my point on g of x. Now, to get the point on g of x, we just inspect the graph. And this point right here, remember, it has to be a corresponding point. So if I were to find where this point is, that has no relevance to the question, because I hope logically that the vertex of the original parabola is not going to transform into just a random point along the transformed quadratic. So in this case, let me get rid of that line, 0, 0, the vertex on f of x, has been translated or transformed to the vertex on g of x, which I hope we all agree is at -4, -5. Now, it is important that sometimes, and this is unfortunate, but every now and again on the diploma or on a test, the scale will be a little bit tricky. So you have to make sure you pay close attention to the graph, and I hope we can all see that every 2 ticks is -2, so every tick is 1. I should say every 2 ticks is a distance of 2, I suppose. So what that means is that 0, 0 was transformed into -4, -5. Now, hopefully it's not too much of a stretch to do this, but we can really say that, okay, 0 plus h then gave me -5, so h is -5. And 0 plus y gave me, there's a little mistake there. 0 plus h should correspond with the x value, so that should actually be -4. And then on the y coordinate, which is the -5, we'll make sure we get that right this time. If 0 plus y is -5, then y is -5. Geez, it's not a good day for doing this. This should be 0 plus k, and that means that 0 plus k is -5, so k is -5. Sorry about that. Maybe take a look through this and pause it at this point and make sure that you have what I have written down. Now, once we know h and k, we're in business, because all we have to do is substitute them in to the transformed form. And that is very, very consistent throughout the course. It is given on the formula sheet. It's one of those things where we have to practice it to get more comfortable with it, but we don't truly need to memorize it. It's one of those things that's better to understand what later on A, B, H, and K are all doing. So with the values that I just determined, I could write that I would have y minus -5 is equal to the function f evaluated x minus -4. Now, those brackets and negatives need to be there, but you would certainly be expected to clean this up and write it as y plus 5 is equal to the function at x plus 4. And a lot of students struggle with the idea that f of x plus 4, and I'm going to write this in, that this statement right here is corresponding to a horizontal translation 4 to the left. And the reason for that is we can actually put a value of x in that's 4 less and get the same output on my original function. And that is a weird logical dissonance. I understand that, but it's one of those things that by doing questions and working through this will become very clear. And it is very, very consistent throughout the course. All right, there's a B. There's always a B. We love these questions typically when we're given a weird shape, and it is a weird shape. I think it's important that you would not be able to generate f of x with a single function. This is a piecewise function. It's likely 1, 2, 3, 4 different functions, and that's fine. The best way of doing this, I think, is to pick a lettered point, determine the translation, and then confirm with another lettered point. And really all I mean by that is I'm going to grab the coordinate A on the original, so I'll put f of x above, And then I'm going to look at, and they identify that as a prime. And that's on the new function, the transform function, g of x. So a on my original function, again, watch that scale, it's at negative 5 comma 2. A on my transformed function is at negative 1 comma negative 7. Now, as we work through these and we do more and more of these, you're probably not going to have to write out all that, explicitly like I did in example A. I hope that we can see to go from negative 5 to negative 1, we move 4 units to the right. And to go from positive 2 to negative 7, I move 9 units down. Now, 4 units to the right is a horizontal translation, and it means that h is positive 4. Very important to identify that it's positive 4. 9 units down is a vertical translation, and it means that k is negative 9. It's very, very important that we make that connection between the language and the value of each parameter so that we can kind of follow the math through from start to finish. So if h is equal to 4 and k is equal to negative 9, then I could write this as y minus negative 9 is equal to the function f evaluate x minus 4. And similar to the last question, not much point in having those double negatives there. And I could write it like this. Now, this is one of those times where we can't really check this via our calculator. So we should at least try to verify it a different way. And I think the best way of doing that, I really like this idea. And admittedly, this is a little bit exploitative of the smartboard. But if I draw that translation, I should be able to use that as a guide from every original point to every new point. So if I draw 4 to the right and 9 down, I can now grab that kind of weird inverted L shape, and we can see that if I put the original point on B, that guides me to B prime. If I put it on C, it guides me to C prime. D would map to D prime, and E finally would map to E prime. Now, one last thing, I think it is important to write the mapping here, that if we talked about f of x, we could take any point on f of x, so A, B, C, D, E, or even the points in between, right? Like that point right there. And what would happen is if we took that point and added 4 to the x value, subtracted 9 from the y value, that would give me the transformed function g of x. And mapping is my preferred technique for sure, because it's literally that. It's a map to take us from the original function to the transformed function, and it gives a lot of kind of, not simplicity, I don't think, but a directness that is sometimes uncommon in this type of mathematics. All right, I'm going to put up that homework page just because I've been kind of remiss in doing that previously. Please do chip away at these questions. The more you do, the more comfortable you get with this. And I can't emphasize this enough. We are not going to stop doing that, or this year. That sounded a little weird, but function transformations are kind of the backbone of 30-1 math. And as we work through the year, we're going to be doing these same concepts with more and more complex functions to really show how true this is in a general sense.